Hello again, welcome back. I have to interrupt the progress of the Kurt Weiss refurbish in order to help out a friend. So today we're going to look at repairing or at least remaking a part for his tractor. This is out of a John Deere tractor, comes out of a gearbox somewhere. Drives a couple of pulleys, I guess. Don't really know a lot about it. This is one of the pulleys that goes on it. And what's happened, over time the bearings that this run in have worn the shaft, and now everything's all very wibbly wobbly, and that's no good. This shaft is just some kind of piece of basic carbon steel. It's not at all hard anywhere. This is just a cheapo file, and I can score this anywhere. So this is nothing special. It's 1 inch diameter where the bearings and the pulley go on. So what I'm going to do is just make a new one. Now I happen to have a piece of leftover 1045 TG&P, and if you don't know what that is, that's turned, ground and polished material. So it's very good quality. It's sized to 1 inch nominal. It's actually usually a half to a thou undersize, because it's made for slip fits into bearings and so on. It's easy to machine. It's harder and tougher than 1018. I don't know if this is 1018, but there's a strong chance that it is, because it's clearly nothing, you know, extraordinary. So this is ideal. That's going to make it easy. All I have to do is machine 3 grooves in it, which are for circlips, retaining rings. Machine in 2 Woodruff key seats and put a hole in it. The hole I'm going to put in it is going to be slightly bigger than this one, so that I can open up the hole in the pulley, which is now, it's a bit oval. Let's see if I can get you a close-up of that. So that's the plan. What I'm going to do, since this is not going to need any finishing on the OD, is I'm going to chuck it up in the 4-jaw and true it in. So first I'm going to true it in with only a very small amount of stick out and put a center drill in the end. And then I'll stick it out further so that I can do all 3 grooves in one go and true it up. It doesn't need to be that level of concentricity really, but I can always use the practice. And you might as well give things your best effort. Anyway, once that's done, then we'll come back to the mill here and we'll put in the hole and the key seats. And it's only once that's done that I'll actually part the ends off and cut it to length. Okay, let's go. Right, I want to show you this tool that Tangent Jim sent me. It's a very nice indicator holder. Works with these quick change tool posts. Now, if you find setting up a 4-jaw difficult, then I recommend this approach. Which is to use 2 chuck keys. Now this should be pretty close. Not even remotely close. All right, 25 thou out, for crying out loud. Right, so I use 2 chuck keys, and the beauty of that is you can play the opposite jaws off against each other and move them in sync and have a lot of control. And then when you're ready to really tighten them up, you can tighten them against each other so that the part doesn't move. Yeah, I mean, do I really want to putz with it? Can't help myself. Yeah, so I think that's plenty good. So this tool is really, really great. It makes it very easy to set this test indicator on center line because you use the quick change tool post to do that. And once there, it's set. You can take the tool holder on and off. But not only that, he's got this quick access knob, and you can turn this to all kinds of angles. So you can really use this for a whole lot of different approaches. And I shall certainly demonstrate that more. But this, so I want to thank Tangent Jim for this, because he sent me this to test out for him on this size lathe and see how it worked. And I've been very, very happy with it so far. Anyway, next stage, just going to put a center drill in the end here, then stick this out and try and get it running true over its full length. Andrew over at Model Engineering Adventures kindly bought me this as a gift, and it's one of these excellent Lin Tailstock DROs, and you can find them on eBay. It's really excellent. It was like 5 seconds to install, and you can take it off anytime you want. I don't see a need to take it off right now, so I'm leaving it there. But really happy with this, Andrew. Thank you very much. Right, so now I get to install and use a fantastic piece of equipment I'm very happy to have. I have 2 new revolving centers. Revolving centers, mind. I looked these up. I was watching one of Max Grant's excellent videos, and this comes up now and again, and he pointed out how these always used to be called revolving centers. Live centers are ones that are run in the headstock. Dead centers are your traditional dead centers. Anyway, I went back to one of my old school textbooks, and sure enough, that's how they used to be referred to. They are revolving centers. And I do think it's important to get the terminology right.
A matter of words, perhaps, but words are important.
Why are words important?
If you cannot say what you mean, Your Majesty, you will never mean what you say, and a gentleman should always mean what he says.
But, you know, terms do change over time. So be it. I mean, everyone knows these as live centers, no big deal. But I now like to call them revolving centers. Anyway, this one and the other one, I bought from Daintree directly in Australia, and they really are, these are really beautiful tools. Just fantastic quality, no run out, and I was able to get, even with the astronomical cost of shipping, I was able to get these 2 shipped for less than a price of one equivalent one from one of the other high-end US brands, and these are easily as good. So really, really stoked and really pleased with these. The guys at Daintree are just amazing, wonderful people, very helpful. Anyway, Okay, so that's under 1. Let's see how that tracks down the length of the part. Let's zero that. Of course, I can't go all the way down the bloody thing because I hit the tailstock. So let's see how the run is there. Okay, well, we're still under 1,000, and I'm going to call that good enough. You know, these are snap ring, retaining ring grooves. So, yes, as you would expect, the shaft's running out a little bit over the length, but not enough to be a concern. So I'm happy with that. What a fantastic tool that is. Thanks, Jim. Okay. So these grooves have to be 90 thou wide, and there goes the compressor. And the groove diameter is 938. So I'm going to set up my DRO at this point. Now that should be 950 or very close to it. And we will find out by the cunning use of a blade micrometer. And you heard that squealing away. I was being far too cautious and far too light on the feed. As soon as I pushed on it a little bit, it quieted down. So it's a good little practice run, this. Nine 0.9508. And I'm not going to piss about with that. So I'm going to now take it to 938 and just check it again. So 925, 935, 939, so 0.9392, 0.9392, which is within the plus or minus 2 thou that I want for this soap. This is going to be my Z0, and I'm just going to put a little scratch in there as a reference. Wonder if I thought this through. Probably not. Oh well. May use flood coolant. Scratch first. No worries. Right, so, well, that was easy, wasn't it? That's the 3 grooves done. I will, well, it doesn't feel like much burr on there anyway. Cool. So what I'm going to do now is take it out, get it over to the mill, and put in the other features. Then we'll come back here and part off. Remembering that when I part off, this is actually the front edge. But I have to put a chamfer on there, which is going to take out most of this little witness groove. And that feature isn't very important anyway. You'll see what I mean. Like I say, this may all be over the top, the kind of effort I'm going to support and keep it concentric, but you got to admit, that went very smoothly. Okay, so I thought I was being really clever to leave this piece of material on there, but it's actually just in the way and preventing me from getting a end reference. I could figure that out, but hell with it. So now I really don't need to clock this in very accurately for parting off. Oh, it's pretty close. But you know what? It's so easy to do. Now I am running coolant for this. Parting off, always use some kind of lubricant. Lock the saddle. I usually go half of my normal turning speed for parting. I'm not going to today just because I've seen some evidence that says I'd be better off going a bit faster. Let's find out. And again, you can't be too delicate. That chatter stopped as soon as I started pushing on the tool. Kind of have to have the courage of your convictions. That went all right. I'll come back and clean all that end up later. Back to the mill. Okay, let's have a look at the milling setup. So this vise is doing most of the supporting really, and that's got all the extra length of material in it. Here's the new part, and you can see that kind of goes with that. I've actually made the retaining ring grooves slightly too wide. Typical on it. I think they'll still work. Anyway, so you can see we have to put Woodruff key slots here and here. So this vise is in place just to support the back end and stop any deflection, so that I can come along, come down, you know, plunge in, out and across and plunge in, and then after that we'll drill the hole. So what we have to do is find that end, locate that end, and then we'll locate the top of the part with the cutter, and then we'll come across and we'll come down the radius of the shaft and half the thickness of the cutter. Woodruff key seat dimensions can be found on these charts. They're generated from these ANSI standards, which you can find in the Machinery's Handbook, but I also recommend these books, these engineers' black books, which kind of distill out a lot of the most used. There's a big one in big print for people like me with poor eyes. They kind of distill out a lot of the most used material from the Machinery's Handbook. So this is particularly excellent. And you can see the dimensions. I used an 807 cutter today. And this is where you can find the dimensions for the key seat. So there you go. I'm referring to my drawing, which is up on the screen over there. So we know that is 4 thou because I measured it after the groove fiasco. I'm now remembering to measure everything. So we can come off the part. And let's just check the thickness of this as well while we're at it. Should be a 1/4 inch, but it might be 255 or something. We have to come down 1/2 inch plus 1/8 of an inch. And this is going to be on the manual hand dial because I still don't have my ZZ axis in place. So 100, 200, let's jump in there. There we are. Now it's a case of plunge in, so I'm going to turn the coolant on. And we're going in 245. I may have bollocksed up the sound on that one. Yeah, we'll find out. Anyway, that seemed to go all right, but I'm gonna slow it down a touch. So I was on 630 and now I'm 375. This is a high-speed steel cutter. I think this might be a little nicer for it. So yeah, 6.625. Yep. Eyes down for a full house. Did I already say that? Of course I did. That's that. And all that's left now is one hole. Apparently I didn't press the record button for quite a lot, and I'm not sure how much I didn't get. But basically I'm just drilling the hole. Now all that's left is clean up and parting off. Right. So according to these, this part is 12.91. Okay. Glad I still know how to read a manual caliper. Right, just think about this for a second, Shakespeare. Okay. This is what I want to do. I'll scratch the end. I damn near made it too short there. I was going to do what I often do for certain operations, which was get the zero that way, but that is the zero that I want. Bloody hell. This is why I don't do this for money. Lock saddle, coolant on. Prepare to get wet because this is going to go on the jaws. Maybe I can keep it off of them a bit. No drama. Well, there we are. Should work. So everything went fine, except that I forgot to measure and check the width of the grooving insert. And that is one of the problems I run into making these videos, is that there's so many things to pay attention to, especially the machining, which, you know, I don't have tons of experience in, and that's where I need to focus the most. And with the camera, that is an extra distraction. And so I missed out that step. So these grooves are 10 thou wider than these ones. Now, they're just retaining rings. And given what this application is, you know, a tractor output shaft or something on a lawnmower or something, I think this is still going to work. So this is also why I don't charge money for these things, because there's no bloody way I'd make it as a machinist. And I can't anyway. I don't do repairs and things for money. That's not a service I offer. This is a friend of mine. That's why I'm doing it for him. Because if you start making parts for money, the insurance on your property goes away if you're a homeowner. And if you try and get business insurance for being a machine shop, it is astronomical. I looked into it and it just wasn't viable. I was hoping to do kind of side repairs like this for money. It's just not possible. Not to the level I wanted to do it. And there's no way I can make money, you know, as a machinist. I'm not fast enough. And sometimes the quality isn't there. Anyway, this was still fun. Mostly went okay, and I think it's going to work. If these grooves cause, you know, end up being a problem, I'll just have to make another one. But so much for that. Other things that came out of it, the tangent engineering tool for holding an indicator for indicating things in is great. Love it. all I've done is use it to true up a part in a 4-jaw so far, and that was great. I had this part in and out of there multiple times, and it was moments to get this running within about a half a thou using that tool. It's just easy because it's always on center, and being able to pivot the gauge means it's going to be very versatile for other things, and I'll show some of those in future videos. So that's that. My Daintree revolving center was wonderful. Love it. That's the first time I've used that one. And I didn't need the slender revolving center. I just wanted to try it. So, but that was great. Love that tool. What else? First time cutting Woodruff key seats. That went great. A little bit chattery, so I need to think about that a bit. I think maybe I could have had the Woodruff cutter sticking out a little bit less, maybe be supported a bit better. But I also feel like the decisions I made, which at first I thought might have been over the top in terms of holding the part, I think that was all worthwhile. I think putting in the revolving center, using the 2 vices, I think that was smart. And so as a result, mostly a good job. So thanks for watching. If you are just waking up to the end of this video because you fell asleep through boredom halfway through, welcome back. And thanks very much for sticking with me. Thanks to all my subscribers, all those who have been with me from the start, and to all new ones, really appreciate it. Just remember, got a giveaway coming up when I get to 5,000 subscribers, a tangent engineering burnishing tool. You know you all want it. And today I acquired an awesome item which is going to be for my 10,000 subscriber giveaway. Oh yeah, don't know when we'll get there, 2050. But that's it for now. That was a fun repair. Enjoyed doing it. Hope you enjoyed seeing it. And as always, may your surface finishes be chatter-free and your dimensions in tolerance. Be seeing you.